In this movie, we'll demonstrate the first Aspire use case, which concerns digital rights management. On the surface, this use case looks like a video player, but under the hood, a lot of DRM and crypto functionality is present to allow the user to watch encrypted movies. So on top, what we have is an application, and this actually is a Dalvik Java application, through which the user watches videos. With this application, he provides rights that contain a content key to the Android Media DRM framework, and this framework accesses several plugins that we implemented. One is a DRM plugin and the other a crypto plugin to verify the correctness of the rights and of the content key, and then to use that key to decrypt media that is obtained from some headend. So the DRM plugin here is responsible for verifying the correctness of the rights and then for deriving keys from those rights, and the crypto plugin is actually responsible for decrypting the movies and for providing other facilities to the DRM plugin. Both of these plugins are actually dynamically linked C++ libraries that will be loaded into the media server and DRM server processes that run as daemons on an Android device. And in this project, the goal is to deploy the Aspire protections on these two plugins. Now, why do we need to apply these protections? Well, there's lots of assets in this application. And in this use case, we consider 6 different types of assets. First, there's lots of keys embedded and used in the plugins. Of course, we don't want these keys to leak, and hence we propose to use the strongest possible protection, and that's white box cryptography. In the plugins, one of the assets that are protected are rights. And of course, we should safeguard the integrity of the rights, and we should prevent forgery. And to protect them, we propose to use all kinds of integrity protections for code and control flow. The rights are actually verified, and the right verification should happen correctly, so we have to preserve its integrity. For that, we want to rely on anti-tampering techniques such as code guards and remote attestation, and also anti-debugging techniques. As a fifth asset, we have application control flow. We want to ensure that certain activities happen in the correct order. For example, rights verification should always happen before the rights are deployed and content is decrypted. To enforce that execution correctness, we want to deploy all kinds of control flow protections. Ideally, we also want to apply data obfuscations, for example by encoding values at certain points and then decoding them later, thus enforcing the correct order of encoding and decoding operations as part of the normal control flow of the application. The overall application also comes with some security requirements, namely integrity and confidentiality. We don't want an attacker to break the way this application operates, and we also don't want him to steal the design and the algorithms used in the overall DRM scheme. So we're going to rely on code obfuscations, control flow obfuscation, for example, by randomized bytecode. And we're going to rely on anti-tampering and anti-debugging techniques. Finally, as the last asset, we consider unique execution. As we're going to embed cryptographic keys in each instance of the application, and as we will distribute those instances with the keys to individual end users, every instance has a unique value. To protect the value of that asset, we have to ensure that no cloning can take place. It's okay if people copy the application, but they should not be able to run multiple copies in parallel. For that reason, we want to deploy anti-cloning techniques.
So, Bart, can you show us the NAGRA video app?
Sure, I started. So first I launched it from the application launcher. Because it's a demo application, it asks for a password, but I can just enter any password and username combination that I like. I can click login, and it logs me in. So now I have the overview of the movies that can be played or purchased even. The ones with a with a green border are the ones that are not encrypted, so those do not invoke our DRM framework. The ones with the red border, those have been encrypted, and they need to invoke the DRM framework that we rewrite. So I'm going to click on one, and because I haven't purchased this video yet, it just shows the poster and asks me to click on it to purchase the video. And if I click on it, it purchases the video and the video starts playing.
Great, thanks.
The Aspire project received funding from the European Union 7th Framework Programme under Grant Agreement number 609734.